Welcome to the Flexible Mind, Machine Learning's New Era. In this episode, AI Frontiers spotlights 56 groundbreaking papers published on July 10, 2025 in Machine Learning. Today, we'll explore dynamic and robust AI architectures, advances in medical AI, and chart the future directions of artificial intelligence research. Let's dive into the key themes and seminal works shaping the next era of machine learning. Here's the roadmap for today's exploration of AI breakthroughs. First, we'll dive into the emergence of dynamic, adaptive models and robust AI systems. We'll unpack major research themes drawn from a survey of 56 recent papers. 3 seminal studies shaping the trajectory of the field will be highlighted, followed by a discussion of methodologies, key findings, and future research paths. This presentation is designed to be accessible to all curious minds. No deep technical background required. Machine learning stands at the core of modern artificial intelligence. It empowers computers to learn directly from data, enabling applications that range from voice assistants to cutting-edge medical diagnostics. The field synthesizes insights from statistics, neuroscience, and mathematics, allowing models to tackle the messy, complex, and constantly evolving data of the real world. Research in machine learning both drives practical innovations and deepens the theoretical foundations upon which the future of AI is built. A central theme emerging from recent research is the rise of dynamic and adaptive model architectures. In contrast to the traditional fixed sequential structure of neural networks, new approaches, such as those by Lee and colleagues, allow models to skip, repeat, or reorder their layers dynamically. This enables faster, more efficient, and more accurate computations, adapting complexity to the demands of each task. Much like the distributed intelligence seen in an octopus brain, dynamic inference empowers models to reconfigure themselves on the fly, representing a fundamental shift in how AI processes information. Robustness, fairness, and security have become critical considerations in the deployment of AI systems. Mehdi and collaborators propose adapting adversarial defenses on a per-class basis to enhance fairness, while Yarkoni and team expose privacy vulnerabilities in generative models. These advances underscore the importance of equity, reliability, and privacy in real-world applications. Security techniques must carefully balance utility with protection, as adversarial robustness, where models defend against intentional manipulations, remains a core technical challenge. Frontiers in reinforcement learning and sequential decision-making are being expanded through innovative research. Dong and colleagues introduce expressive policies that dramatically boost learning efficiency, while Bai and others develop action chunking methods for complex dynamic environments. Reinforcement learning agents improve by trial and error, continually adapting to change. Cutting-edge methodologies bridge the gap between offline data and real-time decision-making, with policy optimization at the heart, training agents to maximize long-term rewards. Multimodal and hierarchical data integration marks AI's next leap forward. Huang and collaborators introduce hierarchical models capable of learning end-to-end chunking of input data. Garrido and colleagues fuse clinical, molecular, and imaging data to deliver superior health predictions. These models adeptly handle disparate data types, images, text, and genetic information, enhancing both accuracy and interpretability, particularly in medicine. Hierarchical structures enable models to capture deeper, more meaningful patterns within complex datasets. Interpretability, evaluation, and model efficiency remain at the forefront of machine learning research. Despoto and team focus on interpretable policy decisions, providing clarity in AI reasoning. Cerny and collaborators pioneer counterfactual explanations for recommendation systems, while Liu and colleagues introduce new metrics to rigorously evaluate model outputs. Efficiency is addressed by Neff and team, who develop pruning techniques for deploying AI on limited hardware. The overarching goal is to create AI systems that are both understandable and energy efficient. Surveying key findings across 56 papers reveals several paradigm shifts. Dynamic architectures, as demonstrated by Li et al., consistently outperform fixed models. Expressive reinforcement learning policies, introduced by Dong and colleagues, achieve unprecedented sample efficiency. Hierarchical modeling, spearheaded by Huang et al., excels in complex domains. Garrido's work on multimodal integration significantly enhances medical predictions. And METI's fairness-aware defenses advance the development of robust and equitable AI systems. A closer look at methodologies reveals how today's advances were achieved. Test-time adaptation allows models to select their computation paths on a per-input basis. Li and colleagues leverage Monte Carlo tree search for dynamic layer selection, optimizing both speed and accuracy. Multitask and multimodal learning approaches broaden generalization capabilities. Causal discovery and counterfactual reasoning contribute to greater explainability. Efficient pruning and imitation learning methods support the practical deployment of sophisticated AI models. Spotlighting the paper Skip a Layer or Loop It, Test-Time Depth Adaptation of Pre-Trained LLMs by Li and colleagues. Their research demonstrates that models can dynamically skip, repeat, or reorder layers during inference, rather than following a fixed sequence. Monte Carlo tree search is employed to discover the optimal layer configuration for each input. This approach yields significant improvements in both speed and energy efficiency, while also enabling correct predictions in cases previously missed. The work represents a pioneering shift toward architectures that are both adaptable and efficient. Turning to EXPO, Stable Reinforcement Learning with Expressive Policies by Dong and collaborators, a dual policy framework is introduced, combining a large, expressive policy with a lightweight edit policy. This system utilizes a stable imitation learning objective to ensure robust training. The result is a remarkable 2- to 3-fold increase in sample efficiency for reinforcement learning tasks. By effectively bridging flexibility and stability, this work sets a new standard for reinforcement learning in data-constrained environments. The paper Dynamic Chunking for End-to-End Hierarchical Sequence Modeling by Huang et al. Introduces HNet, a model that learns to segment and process data end-to-end. HNet outperforms traditional tokenized transformers, especially in challenging domains such as English, Chinese, programming code, and DNA modeling. By revealing the power of learning structure directly from raw data, this research signals a move toward fully end-to-end and domain-agnostic AI systems. Looking ahead, several future directions are anticipated in machine learning. Dynamic and adaptive architectures are poised to become the new standard, while end-to-end learning from raw, unprocessed data is gaining traction. Stronger causal reasoning and counterfactual explanation techniques are expected to enhance transparency. Increasing robustness, fairness, and efficiency will be essential for real-world deployment. The ongoing challenge will be to balance complexity, interpretability, and performance in next-generation AI systems. This presentation was synthesized using GPT 4.1 by OpenAI for content generation, with text-to-speech performed by OpenAI and images generated via Google Tools. A human expert reviewed the synthesized content for accuracy, though some oversights may remain. Please consult the cited papers for full details. All references are provided for those interested in further exploration of the research. Thank you for joining us at AI Frontiers. Like what you heard? Subscribe to our YouTube channel to stay updated on the latest in AI and machine learning. Join our community and never miss an episode. Your curiosity powers tomorrow's breakthroughs. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer, this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.